Hello, how are you? I hope everyone is fine. And today we will discuss about water footprint. This training program is for 3 days, and we have devised this training program in such a way that we'll have some theoretical part and then some practical part on the basis of exercise to calculate the water footprint of an industry. So, first of all, very welcome on this learning platform online session, Basics of Water Footprint. As you know, the water footprint is a measure of humanity's appropriation of fresh water in volumes of water consumed or it is polluted by any anthropogenic activity. And the water footprint, when we are considering here three type of sources, or we can say type of water footprint. So these things we'll discuss later on. But first, we need to understand why the water is important. Water is important entity because this is not only important; it is vital part of the life. Without water, the industry cannot sustain. Human development cannot sustain. The life on planet cannot sustain. And whatever the water we have, that has been either it is locked in the ice or it is available in sea. So most of the water is not potable, which is available on planet Earth. What type of water is available for and that can be potable? It is the subsurface or the surface area. Surface water is especially like in the lake, rivers, canals, etc. And these lakes or rivers known as like surface water because this is available on the surface of this planet. So that is available for drinking purposes, bathing purposes, and all other like irrigation industries, etc. Subsurface, that is known as groundwater. So this groundwater, especially, it is not actually ground, but conventionally we are using the term groundwater. It is subsurface waters, like, and these subsurface and surface water is termed as a fresh water, which we are using for our day to day life in industry, domestic, irrigation, washing, or we can say for the cattle, everything, whatever the activities we are doing, and wherever water is required, we are using that water. Some places, at some places, we can say the marine water is being utilized after desalinization. So what about this water footprint? Basically, water footprint is basically about three things. One is the volume, means how much water is being utilized or how much water will be utilized by specific industry or for the domestic purpose or for any other purposes like irrigation, dust separation, floor washing, product washing, etc. Second point that is again important, where the location of that water. Like if we are using the groundwater, that is of course very important location of that area where you are going to abstract the water, abstract the subsurface water or the groundwater, because nowadays CGWA permission is required for any number quantity in any area in India to abstract water for industrial purposes. However, if we are going to utilize 10 KLD or less than that 10 KLD for drinking purposes for the industry, CGWA permission is not required. Only information is required to the respective board. And third, most important thing is for this water footprint is the type of water. Which type of water you are using for specific purpose or generic purpose. For that purpose only, here three things like volume, location, and type of water. So that is multi-dimensional indicator. So water footprint showing three things: volume, KLD, KLA, A for annum, D for day. Location means where, from where you are taking the source, and type is like your fresh water or rainwater or gray means treated water. Sometimes it is known as recycled water, reused water, or some other terms are also there, treated water. So that is the type of water which we get from this water footprint. Sometimes it is also means it shows about like the time of the season or year, time of the year, in which time, because in the lean period are some other type of seasons, different in dry season, in the wet season, different type of volume is required or quantity of water is required. So it depends on the season as well. In case of irrigation, in monsoon, it is very, very less water is required for green belt and as well as dust separation. Or sometimes it is not required when it's raining there, right? So again, whenever we are putting in that, because we need to make a chart, a bar graph, or any type of pie diagram, which shows about the seasonality of the water consumed by a specific industry. So all these three things basically, and including the seasonality of the water consumed in any specific by the specific industry, that is known as water footprint. If you are going to prepare the water footprint, if you are going to go for a calculation of the water footprint, we should remember these three things. One is the volume of the water, source of the water, and the type of the water. And sometimes we have to also present somewhere that the season, because that can be cleared, that can be shown from your bar chart, a pie chart, or some type of geography, the graphical representation of the water footprint. So these like volume, location, time, and type of water is used for the production of a product over the whole supply chain in a year. Water footprint is basically we have to calculate for 1 day for 1 year, and we have to present, because in case of year, the average water footprint will get from 1 year data. So in case when we are getting 1 year data, that is basically water budgeting. If we are calculating for proposed industry, suppose we have one industry that is proposed, there is nothing has been done at the site as of now. So what we have to do in that case, we can calculate the water footprint for 1 day or for 1 year. The same it will be. Same means average will be same. In case when the industry is already running, so the fluctuations of consumed data will be there, because it is not a type of one requirement in the lean period or another like some other period. In all the days, seasons, or we can say the time, it the water requirement will be different. So in that case, we get the average value, and that will come from the annual consumed data. And for this reason, we should, or simply not we exactly, the industry should install flow meter. And also, if they are eligible or they have the CGW permission, so piezometer will be also there within 50 meter from your borewell. So in that case, that all these things we have to verify from the site visit that they are complying or not, and piezometer has been installed within 50 meter or something, and also the flow meter has been installed, and it is running, it is in calibrated, everything we have to check. And also we have to have some tools to measure that we will discuss later on, how to conduct the audit, how to prepare the budgeting, water budgeting, and this water footprint. So the water footprint is basically, as we have discussed, like amount of water used to produce each of the goods or services, whatever the industries are providing, goods, materials, product, services like transportation, are they are doing giving services. It can be measured for a single process, like a one beef production from cow or something. Our domestic requirement was a single requirement, and also growing a rice is a one single process. So that water footprint can be done for a single process, single industrial process, or a product, or number of product. It cannot be like, we cannot say that only one product required water footprint. We can calculate. We can calculate water footprint for multi-product and single product as well. Our number processes, complex processes, simple process. Like steel industry, integrated steel industry, chemical, pesticide, cement industry, anything. Whatever type of industry, whatever type of services, organization, school, college, anything. For like carbon footprint, as you know, in case of carbon footprint, every organization can do. For every activity, we can calculate the carbon footprint. In the same way, the water footprint is also can also be calculated for anything, for any process, single, multiple organizations, individual person, in case of residential complexes, city, the means whole country, and then global level, right? So the water footprint can also tell us how much water is being consumed by a particular country or on a global level in a specific river basin, like the source of water are from any particular aquifer, because source here in case the how much volume, the location is the source basically, and the type of water. These three things are there in the water footprint. And also whenever we are presenting the graphical presentation, then seasonality will be also there. So all these four things are there included in the water footprint. The water consumption for different type of product consume different quantity of water. It is not like 4 kl per kl of ethanol production in case of generally to green bed distillery, or 8 kl of 1 kl of ethanol per kl of ethanol for molasses based industry, or some steel industry, or megawatt like thermal power industry. Single product for any type of industry which had a single product, specific consumption is already there, has been fixed by CPCB and CGWA. Simply we can say by the government of India. But in case where the multiple products are there, like pesticide industry, or the chemical products, chemical manufacturing, specialty chemical, or petroleum product, etc. Sometimes the means some products are not required any amount of water, fresh water. So in such cases, specific consumption has not been fixed. So there, because of the water consumption in different ways for the product of different country type of category, so there is a huge variation and around global average. Even the water footprint of the same type of industry by different organization is different. Like if you say 100 tons per day, means one industry they are manufacturing the specialty chemical in Gujarat, and somehow in the same type of industry, same type of product they are manufacturing in Maharashtra, they should have the same consumption. It is 99.99%. No, they are not consuming same type of, same amount of, same quantity of water. So there is also a variation. For these variations, to fix these variation, the water footprint is required by all, by specific industry, by all type of industries. After this, after the huge data, after the accumulation of this type of data, ministry or these type of agency who are monitoring agencies like CPCB, MFCC, and CGWA, they will fix the specific water consumption so that no one can withdraw more than that or above the specific water consumption. Also will we have an exercise to calculate the specific water consumption, like how we can calculate the specific water consumption, that we'll learn later on. So the precise footprint of a product making depends on factors, some factor variable factors, such as type of production system, how they are managing, how they have different type lines, production line 1 to 3, and the composition of product and origin of the raw material, and from where the raw material is coming. I hope you must aware about life cycle assessment. If you are aware about life cycle assessment, in case of life cycle assessment, water footprint, carbon footprint, sequestration, everything is included in the life cycle, because life cycle start from the scratch of the raw material, means extraction of the raw material, transportation of raw material, loading, unloading, then storing, and then processing of raw material, production into this, like raw material to product, conversion of this raw material into product, then again storing the raw material product in stock or somewhere in the godowns, storage area, then again this transportation to the warehouses, then it is reaching to the end user, consumption of this product, then discard like waste, and then recycling or reuse or dumping, or simply we can say the disposal of that waste, and then disposal, if this is being recycled or reused, then again the cycle will go on going on. So this type of whole consumption in term of energy is known as life cycle assessment. And whenever we are calculating the life cycle assessment, so because it is in the term of energy only, but here the water consumption, the fuel consumption, everything we have to calculate. So the water footprint is one part of life cycle assessment. Here in this case, water footprint, we have to means calculate the water consumption for the product, not only production, the processing, the separation, domestic purposes in that industry, water being utilized for anything, to run the company, to run the industry, for because for production, number of manpowers are there, area involved, land involved, means plantation is also there, transportation is also there, the separation, irrigation, green belt irrigation, domestic requirement, many other things are there that we have to calculate for that particular industry. Ultimate consumption of water by a specific industry to produce number of product in tons or some tonnage production in 1 year, then we have to calculate water per ton of the product, like kale per ton of the product. This is known as specific water consumption. So here are some data. The global water footprint of humanity in the period of 1996 to 2005 was calculated by some researchers, and they found that about 9,087 billions of cubic meters per year, and in which about 74% is the green water. And this green water is basically what? The rainwater. 11% is the blue water. What is the blue? This is the fresh water. Is this fresh water include the surface and subsurface water? Simply we can the surface and groundwater. And 15% gray water, and this gray is means treated water, the sewage water, which has been treated now and can be recycled or reused. And for agriculture production, because water is maximum water is being utilized in agriculture production. So for agriculture production contributes 92% of this total footprint, which has been like 9,087 billions of cubic meter. Water scarcity affect over 2.7 billion people for at least 1 month each year. And for this reason only, the water scarcity in many area is of course increasing day by day. Aquifer are shrinking. So now, water footprint in each stage of supply chain of any animal product or something, like here you can understand one example: animal products. When we are consuming any product, so that means we are not consuming the direct water, but also indirect water we are consuming. Like, first you can see feed, like in feed crop cultivation, like rice or wheat or anything, whatever we are going to utilize, that has been already cultivated somewhere and they are using the water. So this is known as direct water footprint. Then what will be the indirect? This feed crop cultivation can will be utilized by any live stock or any animal, that is known as indirect water footprint. And livestock, sometimes this livestock are, we can say animals, these animals are consuming the direct water, so that direct water they are drinking, that is known as direct water food. But whatever the feed crop they are cultivating, they are using for eating, so that is for this direct footprint for feed crop cultivation is indirect footprint for livestock farming. Then this direct and plus indirect footprint is becoming now indirect footprint for food processors, and food processors are also using indirect, sorry, direct water for washing, for cleaning, many things are there. So that is what direct footprint. But now food processors are using this plus this and plus this, three water footprints are being utilized by food processors. Mm. Actually, they are using only this water, but indirect water is being utilized from this and from this. Then this is going to retailers. Retailers are, they are means using water for cleaning or something. Very means less amount of water they are using direct, but indirect water will be this plus this plus this. These three water footprint is indirect footprint for retailer. And now we are the consumer. So again, we consuming water means the cleaning, cutting, cooking, etc. In houses, and also after eating, the washing of dishes, etc. That water is consumed for the that purpose only. So this is the direct consumption, but indirect consumption will be this plus this plus this plus this. Means consumer is actually using a huge quantity of indirect water footprint. Direct footprint is very less, because here you can see, suppose they are using 100 liters, so livestock can use only 50 liters, suppose. Now food processor using 20 liters, retailers 10 liters, and consumers 5 liters something. So in direct consumption, direct water footprint for consumer is very less, but indirect footprint is very high, because for this consumer, the water is consumed by 1, 2, 3, and 4 stages, and this is known as life cycle assessment. Total, if you are means calculate, we are calculating from this. So this, like in case of one example, 1 kilogram of beef requires approximately 15,000 liter water. 15,000 liter of water. Why? Because you can see it is indirect water flow, not direct. Direct only you can use 3 4 liters for cooking and eating, etc., and drinking the water. But indirect footprint is very very high. So this water footprint, what allow us to know: one, where is the water dependence in my company's operation or supply chain? Means the area, those area to identify where water dependency is more. And also, how well are regulations protecting our water resources? How secure are our food or energy supplies? Can I do something to reduce my on water footprint? And also, this help to manage water for people and for the nature as well. So from water footprint, because everything tells us about reduction of its impact, and footprint is the impact only. Like carbon footprint, when we are calculating the carbon footprint, after knowing that these area are very much emit, means we can say carbon emission is very high in that area. So what we can do now and how we can reduce. In same way, here in the water footprint, we will get to know that which area, which productions in supply chain are in operation are water dependence, and high quantity of water is being utilized for those area, and how we can reduce. If we get to know that these are the area where much water is being wasted or is being utilized, so now we can introduce green water or the gray water instead of blue water. And the objective of this water footprint is to save, to reduce the water footprint term of blue, basically. Means the blue water footprint should be reduced. Why? Because I said more than 98% of water is not potable. So you can, means we all are aware about this fact, and whatever the 2% is the blue water, that blue water is very less, and population is increasing day by day, industry is increasing day by day, and our demand is increasing day by day. So that means we have to save the blue water. And blue water is what? This is the surface and subsurface water or potable water. Of course, rainwater is also potable, but rainwater is renewable. But blue water is not renewable, so we have to save the blue water. Now, we need to know the color of water food. First color is green water, and green water footprint is basically it is available in the root zone of the soil, evaporated, transpirated, are simply known as rainwater, precipitation that is available in the nature by the plants, by any surface area, and this is relevant for agriculture, horticulture, forestry product without any treatment. Because for the rainwater, we are sometimes it is being utilized in agriculture, horticulture, forest product without any treatment, but it can be also suitable for drinking. If we have to treat somewhere in PTP, primary or preliminary treatment, so that can be also utilized, right? So I hope you got this point, that what is green water food. Is it clear now? Okay. So, green water footprint is the rainwater, the precipitation that is stored in the root zone of the soil, and it is evaporated, transpired, evaporated by incorporated by the plants and available in the atmosphere as a rain. That is known as green water. And this water can be utilized without any treatment for especially irrigation or in agriculture, horticulture, forestry product, right? And another one is, and very important, because the main objective of this water footprint is to save the blue water footprint, right? To reduce the blue water footprint. And footprint is the impact. So water footprint aims to reduce the impact, right? So blue water footprint is water that has been sourced from surface or ground water. Simply we can say surface, subsurface water, and those resources which is logged somewhere, it is potable, like underground aquifers, it can be evaporated somewhere, if it is evaporated available in the what environment, in the atmosphere, in the plant, in the soil, that is not blue. Soil means soil as a moisture. It is not in the aquifer. If it is in aquifers, then it is known as groundwater. And some, if we are using groundwater, the surface water available in the lakes, rivers, etc., ponds, that means this is the blue water. So there is a difference. Whatever the moisture available in the atmosphere, that is known as, either in the plant, either in the soil, is known as green water. Whatever the water available in the aquifers are on the surface, like not marine. You cannot include marine water in blue water. Like sea water is not included in the blue water. Of course, it is blue. Color is blue. That is okay. Here, the term blue water is potable water includes one surface, second groundwater, or simply subsurface water, which is being utilized by industries, by the population, by human. That is blue. So this can be evaporated, this can be incorporated into a product, can be taken from one body of water, returned to another, returned to a different time period also, we are consuming water and returning to somewhere else, right? And it can be irrigated agriculture, industry, domestic. It can be utilized by anyone because this is available and potable water. Sometimes it is requires some treatment, like high TDS can be removed by reverse osmosis. And third one is known as gray water footprint. The gray water footprint basically is the amount of fresh water, and fresh water is surface and subsurface water, means blue water. Or simply we can say the amount of blue water to assimilate pollutants to meet specific water quality, or assimilate the pollutant to meet the quality standard that can be reused or recycled. Means sewage can be treated by applying STP, and whatever the water we are getting, that gray water, can be utilized. Simply we can say recycled back to the irrigation, something, dust separation. That is gray water. Sometimes we are using black water. It is not included in the water footprint because this is untreated. Wastewater, effluents, waste, etc. That is untreated. When we are treating this, after treatment, that can be recycled. The water which is treated, the wastewater which is treated by some technology, that is termed as a gray water. And this gray water can be recycled in the processes, or we can also discharge into any freshwater resource directly through a pipe, indirectly through a runoff, leaching from the soil, impervious surfaces, or other diffuse sources. So, what is the importance of this water footprint? I think you got this point that footprint means impact. Water, of course, this is the water. So the water cycle, we are not going to discuss about the hydrological cycle, water cycle, how it is stored, how it is means condensation, precipitation, runoff, groundwater store, transpiration from the plants, evaporation from the oceans, lakes, streams, etc. It is happening in the atmosphere, right? So water is renewable and constant total amount of water recycling through the environment is known as water cycle. And when we are having this blue water, the gray water, the green water, and we are using this water, either type of like green or blue, because gray water cannot be consumed by animal. Sometimes the animals are of course using without knowing or something, or we can say we are using blue basically. Sometimes animals can use green water, right? So that type of water, how much quantity of that particular type of water, and where it can be, where from where it is taken, the source, and how much quantity, we have to calculate the impact of water by the industry, like how much quantity of water they are using, how much water they are converting into the wastewater, and how much water they are actually recycling. If they are recycling, that means they are reducing their blue footprint. So the water can be utilized for any activity like power, recreational, industrial, home houses, agriculture, recreational use, agriculture use, many things are there. So that is of course available and we are using every day in our life. Every day we are using in the houses, in the societies, functions, celebrations, industries, organization, private colleges, school, everywhere we are using the water. So there are seasonal variation of course. In the winter season, our intake demand is very low. While in the summer season, our intake demand is very high. So I think you got this point. Like variations are there depending on the season. In the same way, we have to present the water footprint in seasonal variations by consumption of water by the industry, by the specific industry, like steel industry, cement industry, chemical, fertilizer, synthetic organic chemicals, rubber, paint, pesticide, anything, oil and gas, petroleum, etc. Even the mining or any type of highway, irrigation projects, river valley, etc. So, due to dependency and temporary limitation of fresh water, a water footprint can help to identify products that can be risky to produce at a certain location and also certain period of time due to water scarcity. And this water footprint can achieve a more sustainable and equitable use of fresh water because we have a clear picture where the water is being consumed and what are the area of improvement. So what is the relation between the consumption and water use? Here you can see whenever we are going for calculation of the water footprint, that means we have to recognize the impact of any industry on freshwater system because as I said, sorry, most important are simply the objective of this water footprint is to reduce the blue water footprint, a blue water. So reduction in what blue water means we have to explore other area because industry cannot run without water. We cannot close the industry. We cannot temporarily close for some time to reduce the water content. No, we have to explore some other area, and those area are the green and gray. Green and gray. Green means the rainwater, the precipitation water, and gray is the treated water. Where is the shortage, water shortage or pollution is there, then we have to treat the water. We have to go for the ZLD. I hope you are aware about the zero liquid discharge ZLD system. It is applicable, of course, by 17 type of 17 categories of industry. It is not only limited to 17 categories as addressed by CPCB, but any industry which is going to establish nowadays, they have to go for ZLD if there is common treatment. Their common treatment is not available. In case there is no optional or no common treatment facilities available, they have to go for ZLD. Right. So here in India, this practice is now very common by the EAC when we are going for environmental. Many other countries have significantly externalized their water footprint. They are like one example is Singapore. So they are importing water intensive goods from other countries or other parts of the country. So this what type of because they are reducing their water footprint in that area because location is also important. This puts pressure on water resources in exporting regions where too often mechanisms for wise water governance and conservation are lacking. In this case, like in case of water consumption, not only the government but also the consumers like we, us, the business, businessmen, industries, civil society, communities can play a role in achieving a better management of water resources, because water is precious for everyone, not for only government. So this water footprint can be applied to any type of process, step of any type of production, product capacity, production, person, a consumer, for a community, for a business, for organization, institute, for any area like irrigation, agriculture area, for the city, for the state, for the country, or humanity at global level. So, like if we are calculating the water footprint of a person, in the same case as we have discussed in the carbon footprint of one person, so here also we can calculate the water footprint of a person, or for any person, the total of water footprint of the product that we are consuming. A product water footprint is the sum of water footprint that all process steps that make a product, whatever the products we are using. See, there are two type of water footprint. One is the direct, another is the indirect. Direct you can calculate. Indirect we have to take secondary data, because we cannot exactly assume everything. So we should rely on some other secondary data. Primary data is only the direct water footprint. So whenever you are calculating the footprint, then you have to go for, you have to write the direct water footprint, indirect water, because whatever the consumption, direct consumption by the industry, that you are calculating on the basis of daily or annual, it is known as direct water footprint. But what about those raw material which has been already processed somewhere else? Because whatever the raw material you are using, that can be produced at some place by some industry as a product only, right? Now you are transferring, you are transporting those products as a raw material for your company. Now you are producing though from those raw material into another product, and you are calculating water footprint which had been already, means directly consumed by your industry. So that is the direct water footprint. But another water footprint is the indirect water footprint, which has been already consumed by those industries for production of 1 ton. For that purpose only, we have to have specific water consumption. To calculate the water footprint, we should have a specific water consumption. If we have a specific water consumption, then immediately we can calculate the indirect and direct water footprint. If we do not have the specific water consumption, then we can only calculate the direct water footprint, not indirect. In that case, we have to take data from those industry, or we can refer the water footprint of that industry, and on that on available data we can calculate, we can produce here that indirect water footprint is this much. And it is not a easier task. If you are going to calculate indirect water footprint of any industry, it's a tedious job. Here you can see how, means any type of water footprint of any process or industry can be calculated. First, we need to understand type of products, what type of products they are manufactured, how much quantity of the product. First is the variety of the product, quantity of the product, and then we need to know the source of water, from where the water is sourced: groundwater, surface water, rainwater, or we can say any other type of, so like desalination, any other sources, by how this is being transported by pipeline, by tankers, or by your submersible pump, or bore well, or dug well, any type of lakes, reservoirs, river, canal, French well, intake well, the source we have to identify. Now, the type of utilities they are having, and those utilities, how much water is being consumed per day. Water balance is already there. but exact water calculation will be there in the water audit if they have done. Otherwise, you have to do the water audit again. And here you have to understand two things. I said water footprints of two types. One is direct water footprint, another is indirect water. Now again, two things are there. You are going to calculate two scenarios. One is proposed scenario and another is expansion scenario in case of environment clearance, right? So in case of proposed, that means only, means now industry is not running. If industry is not running, that means you can calculate the water on the basis of understanding from the mass balance. If industry is already running, means second scenario, that means expansion. In expansion, we have to calculate exact data. We have to take the data, we have to collect the data from that industry on annual basis for every utility, for every unit, production lines, and other facilities available within the industry. So process water footprint, we have to add all the water footprints for all the process in a production line, a production system of a product, or number of products. That is the product water footprint. Only product, not human consumption or something. Then also we have to go for the other consumption, like by domestic manpowers are there. If we are using energy, captive power plants are there. So we have to take all those consumptions separately, sector wise or segment wise or something. So and then that is direct one, right? And if all the, like whatever the raw material we are using, so that indirect footprint is also we have to calculate on the basis of specific water consumption if applicable. Why I am telling here the if applicable, because I said it is not feasible and there is no any such criteria for specific water consumption had not been fixed yet for all type of industry. In such cases like chemical industry, paint, of course, rubber industries, paint industries, pesticide industries, multiple products are there. So in that case, when a specific water consumption not there, then you have to rely on the water audit of those industries where from where you are getting the raw material. If it is specific, like one product, like steel industry, energy, distillery, etc., where type of industry is based on only one product. In one product, the specific water consumption had been fixed. On the basis of specific water consumption, we can calculate the indirect water footprint. So now indirect and direct, you have to calculate, you have to show. Then you have to show the percentage of the green, gray, and blue, of course. That is the scenario. Whenever we are presenting annual basis, the seasonality will be there, fluctuations will be there, variations will be there. So all four things, the volume, quantity, location means from where we are sourcing. Blue is either from the ground, subsurface or surface water. Green means the rainwater. Gray means what? The treated water. So source is already there. The quantity, percentage you are mentioning, right? And seasonality, time variation is already there. So all four things are there in the water footprint. The global scenario here, you can see the various standards are there for water footprint. One is global water footprint standards available, that is most well known, and this accounts for direct and indirect, as we have already discussed in the previous slide. Whenever we are calculating the water footprint, we should not ignore indirect water footprint, indirect water consumption, right? So water consumption and water pollution can be there in the water footprint when we are having the gray water, right? So water footprint for fresh water is known as blue, the rainwater the green, and the fresh water required to dilute the polluted water to acceptable quality are for recycle reuse is the gray water. The total water footprint is the sum of blue, green, and gray water. Means whenever we are saying the water footprint means everything will be there, either zero or something. Like sometimes we have a zero of green, there's no problem, but there should be green. there should be blue, there should be gray. Without these three things we cannot present. So in case of life cycle assessment as per ISO 14046, it is already given, as I have already told, that water footprint and carbon footprint are the part of life cycle assessment. Cradle to cradle, cradle to grave, a cradle to gate. Anything, if we are going to calculate, then we have to calculate the carbon footprint, the water footprint, and other activities, the energy consumption in sourcing of those things, those activity, doing those activity, that is life cycle assessment. So under this ISO 14046 or 14,000 series, it is known as IMS. So in this IMS system, ISO 14,000 series of 46 is for LCA provide the norms for water footprint, how to integrate into the LCA. And this is of course applicable, but it is not mandatory activity is being or to be done by any industry. However, now the EAC is giving a standard thought to calculate the water footprint for either type of like new or expansion or modernization. So the global water footprint standards are they are like direct and indirect. So both things you have to calculate at one time whenever you are going to calculate the water footprint, direct and indirect. And it should be not one like green or blue or only the gray. We have to calculate everything either zero. If there is no rainwater, no problem. You have to put zero in gray. Oh, sorry, in case of green. But green water should be there. How much water you are consuming, how much water you are sourcing from different sources, and how much water you are recharging to the wells ground, how much water you are storing at source and recycling, reuse at the source within premises. And then this green and blue water can be converted into the gray water or polluted water. Suppose you have water like X plus Y. X is green, Y is blue. So gray water will be X plus Y. Why? Because total water you are converting into the waste. But if you are recycling within the system, that means you are saving the blue water and gray water is being utilized in the system. So gray water will be again means going to recycled back or reused by putting condensation on the cooling towers or the boilers, etc., or by treatment system giving by means as ETP, STP, MWE, etc. So that can be reduced. That is return flow. And if it is return flow, that means you are reducing the impact. So first is blue water. Blue water is the consumption of fresh water which is available on the surface or in the subsurface. It is also known as ground. So this blue water taking into account the water that evaporate and transpire, and it is incorporated into a product. Like whenever we are manufacturing the production line of products within the system, like steel or chemical industry or any type of production lines are there. So that some water is contained by your product, and some water is evaporates, some water is lost. Sometimes we can say by the cooling towers, or sometimes evaporations by the storing in the open. So that cannot be returned to the same catchment area, but might return into the another area, which we cannot recover, but it is available in the atmosphere. And also Sometimes the evaporated, whatever the evaporated, it cannot be available in the same period or same type of season. So depending on the area, depending on some environmental factors, the blue water consumption, direct consumption from surface or subsurface, and subsurface the groundwater. Now green water. Green water, as you know, green water is basically water which is contained by the soil or by the plants. And also we can say it is available in the atmosphere. This is available in the form of rain. This is also evaporates, transpire from the field and plantation. It is incorporated into the harvested crop or wood. So that is the green water. And if we are using the green water, that it means rain water. That means we are reducing the blue water footprint. The gray water is the consumption of fresh water that is required to assimilate the load of pollutant based on the natural background concentration and existing ambient water quality standards. If we are recycling back to the process somewhere, that means we are reducing the footprint. When we are reducing the footprint, so that means gray water is going to reduce. Whatever the because whatever the polluted water, the wastewater, if it is going to be mixed with the fresh water, any lake, a river, pond, a riverine, any stream, any water body, that means it's going to pollute that stream or that water body. So if we are recycling back, simply we are giving the treatment under ZLD or something, that means we are reducing the footprint and the wastewater is not being discharged into the any river or any water body. So the concentration or the assimilation capacity cannot is not required to add the fresh water. If we are not going to add the fresh water, that means we are reducing the blue water footprint. So what is the difference between this virtual and water footprint? Virtual water, when specific water consumption, and specific water consumption is only for the product. So that is known as virtual water. Application is only product, and dimension is the volume of consumed water for 1 ton of production capacity. Like 1 ton of steel, 1 ton of distilled water, distillery or alcohol, 1 ton of any product. So whatever the kale of water or liters of water required to produce 1 ton of product is known as virtual water. But in case of water footprint, we are covering everything. We are including product, consumer, producer, nation, humanity, etc. Means every direct, indirect. In virtual, only direct water consumption in production per ton. But in case of water footprint, we have to include the water consumed by the person who are working on, the water consumed by the green belt, irrigation, dust separation, cooling towers, anything, whatever utilities are there, even the visitors, everything we have to calculate in the water footprint. Dimensions like volume of consumed water, what type of water source, blue, green, and gray, location, and time of withdrawal. Like here, some examples are there. Like if we are going to use any product, so how much water is being utilized, and which type of water. Here you can see the green and blue, and this is gray. And here again you can see this is the green, and this is the blue, and this is the gray. Green, blue, gray. So total water footprint for sheep meat of 1 kg is required about 10,412 liter on average. 1 kg meat of sheep. 1 kg of potato requires about 287 liters of water, and one shirt, t-shirt or shirt, anything of 250 gram requires approximately 2,495 liters of water. So, and such way, like you can see, In case of 1 kg of meat requires huge amount of green water, because this going to consume what? This is going to consume the feed crops, grasses, etc. And grasses have maximum of green water. So that is they are consuming. And in case of industry, we cannot use the plants directly, but we can use the rainwater, precipitation. So that precipitation, rainwater is green water for us, and plants, crops, etc., which is contained like water contained by the crops, etc., and being consumed by the sheep or any livestock, that is the green water. So animal products generally have a larger water footprint than the crop products, because if you are going to consume the direct crop, means they are not consumed by someone else. That means less green water footprint will be there. Primarily because animal need more time to grow and need to be fed. 98% of animals water footprint due to the feed only. So in case of the animal product, the green water footprint will be more a higher. Now, the national water footprint, you can see this is one data which has been already done in 2011, which we are here presenting. National total water footprint consumption of at global level. The data presented here in meter cube per year per capita means this here you can see India having only one color, right? And this like we are on the safe side. 550 752,000 liters per day per year per capita meter cube. It is in KL. Meter cube means 1 KL. So 1,000 KL per year per capita is being utilized in India. And in case of like here you can see more than 3,000, it is red, and some part of the globe having very few countries are using more water, and some are in like more than 2,500 or 3,000. So this type of water footprint can be there, and we can have for the industry. It is for the nation, for the country, for all the countries. But we should calculate. We are going to calculate for one industry only. So, what is the importance at national level? Because national water plants are there, and CGWA, CGWB is working on that, and water saved in our country, but neglecting that national consumption might be unsustainable on a global level, because aquifers are shrinking. So there are some policies, water policies are formulating that protect the world scarce fresh water sources, because you might be aware about Latur area in the Maharashtra, or some other even Kutch drought prone area. So that is means this is not available. The drinking water is not available. So water footprint assessment is not means it is not having only sustainable things. We can prepare the water footprint and it is sustainable. No, we have to calculate exactly the requirement, the consumption, direct and indirect. Then we have to see the area of improvement for the sustainability. So it is, of course, a type of exercise toward the sustainability, and we can compare the water footprint with the availability of the water in any affected area or in the affected water body or polluted water bodies at the location and time of withdrawal. Then we can also prepare the water risk map, and it is already available. Water India program in our country also. It is not in different country. Here in Water India program, it is already there. Water map is available online. So on this, like whenever you are going for any specific industry, this is India Water Portal. So this India Water Portal here, you can explore the maps and the water footprint. I will share the link so that you can also access this. So environmental impact or a social impact, and the third one is the economic impact. These are the important vital part of the life, of course. So social is the basic human need in the catchment area and fairness, and economic means the price of water versus its real economic cost we have to assess in water footprint. Like when we are going to assess the water, we are presenting the water footprint in the terms of gray, blue, or green. Also, the cost will be there. Responses strategy we have to formulate on the basis of the cost of the water. Whatever we are calculating, the rainwater, gray water, treated water, recycled water, something that we have to provide in that way that we can put the cost per liter or per care. That is also important aspect of this water footprint. So thank you very much. If you have any question, you can mail us here. The details are given like email, and also we have website. Here you can ask your questions on web mail. Like I will show you. If you're going for Akon, here you can click contact us. On contact, fill your name, business, email address, your phone number, and your question. Here in the business, you can type your training program, like training on water footprint, print on here you have to put the date, right? And then you have to put your query here. After query, you have to submit this here. After clicking this, this will come to me. Like suppose I am putting something email, you have to fix you whatever the email you are having, that you have to provide complete correct phone number and email address you have to submit. After submitting your query, it will come to us immediately and we will reply your query immediately whenever we got your question, right? So for first day, this was the basics of the water footprint, type, applicability, etc. So now we'll move to the next day and we'll meet very soon. If you have any type of doubt, you can also WhatsApp on this number. First number 9909968953. Email on this or a web mail also we have shared. So that's all for today. And apart from this, we have some other training programs like remote sensing geographic information system, and like 3 day program, 2 day program, 1 day program, 3 month program, some live sessions, some recorded session. If you have like you are interested for recorded session, we have many such programs, and if you are interested for live sessions, we have one-to-one interaction also. So but different fees applicable for different sessions. It is not fixed for every session, right? So that you have to check before enrollment of any training program. And thank you very much. Thanks a lot being here. Thank you very much.